Good morning, students. Welcome to HashLearn. So we'll be continuing now with the computer aptitude second session. In the first session of computer aptitude today, I have covered for you a very important topic that is based on the base system, binary arithmetic, and logic gates. And as I discussed with you in the previous session, that in the IBPS PO as well as clerical mains paper, now there is a reasoning plus computer aptitude. From last year we have been seeing that, and the reasoning plus computer aptitude paper has a total of 45 questions, and out of the 45 questions, around 8 to maximum 10 questions will be from computer aptitude. And if you do some of the computer concepts properly, you can score out of those 8-10 questions, you can score full marks. And that's why we are discussing in two sessions some of the very important concepts. Now in this session, I'll be focusing on computer networks. It's mostly theoretical, so I'll take you through the theory part of computer networks quickly. You can take down some of the important notes and understand what is the scope of computer networks from the bank exam point of view. Okay, so even if you're a student from the engineering background or non-engineering background, if you have not done computer science or studied this chapter in your school or college, still you can grasp over some of the key concepts here. Okay, from computer networks, we will try to understand that. So let's start with, first of all, the goals of the class. The first and foremost goal is to understand the basics of computer networks and the types of networks, which is again a major part in the examination. Also to understand the types of network devices. Okay, so these are the three major points that I'm going to cover in this session for you. And so we start with, first of all, what is a computer network? Now, when we say in our day-to-day life that I'm connecting to the internet, right? So you're using a mobile phone and using a 4G connection or your Wi-Fi, broadband-based Wi-Fi, you connect to the internet. The word internet itself means a interconnected network. Is that internet? So interconnected network. So two networks are connected. A network is always when we are connecting different things. So we can have a network of people who are all connected with each other. Similarly, a computer network means a number of computers that are connected to each other. So you can see here, this is what is a diagram. So you can see here these computers, how they are connected to each other, and that means once they are connected, they can share information. What is the main purpose of connecting computers? Is to share information. And so how do we define then? The computer network is used to mean an interconnected collection of autonomous computers. Okay, so in short we say interconnected network of autonomous computers. Each of these computers is an independent unit, and we have connected them through some technology where they can share their data as well as peripheral devices, and that's how they can have a combined computing power. Two computers are said to be interconnected if they're able to exchange information. As I've been telling you, the main purpose of connecting computers is to exchange information. They can also share the hardware, and they can share their computing powers and increase the overall computing powers. Okay, so that's a quick understanding of what is this word computer network. All right, now let's see what are different types of networks that from a basic point of view. So I'm saying this paper, when you look at the IBP's PO eligibility criteria, it does not say that you have to be a BCA or MCA or a BTech in computer science or electronics. It's an examination open for all graduate students in India. So a student who is a graduate in arts or commerce, maybe he has not been that familiar with computer science. What is the scope of knowledge that is even expected of him? And that is to at least understand these terminologies like LAN, WAN and MAN, because these things are taught even in school nowadays. So what is three types of networks that we're talking about? One is LAN, that is a local area network. Second is WAN, that is a wide area network. And third one is MAN, which is metropolitan area network. A local area network is the shortest of these three. The smallest in terms of geographical range is a local area network. A local area network could be in one building or even in one small office with 3-4 rooms, having 5, 6 or 7, even 10 computers. We can connect the computers to each other using the LAN cables and Ethernet cards, the network interface cards, and even without using internet, these computers can then start sharing information among each other. So a LAN is the smallest among these in terms of the geographical reach. It can maximum be going into one campus. So let's say, for example, there is a college campus in which there are 5-6 different buildings, and in each building, for example, in an engineering college, we have a mechanical department building, a computers department building, an electronics department building. There's a library separately. So all of these things are connected through LAN. So even it could be extended from one office space, one building, to a number of buildings inside a campus that could all be sharing one LAN, that is local area network. Next is wide area network. This is a wider area. It covers large geographical areas. So biggest in terms of geographical area in among these three here that you see is wide area network. It can span towards the entire country or even between countries. One of the best examples for a wide area network could be internet. Internet itself is a wide area network. Or other examples that you can talk about wide area network could be the railway reservation system, airline reservation system, and most of banking system. All of these things are examples of wide area network where computers spread across the entire geographical area are connected to each other and they can share information with each other. Third is the metropolitan area network. This is the between LAN and WAN. So it is bigger than LAN in terms of geographical area and smaller than WAN in terms of geographical area. What could be an example of a metropolitan area network? Let's say, for example, in a city like Bangalore or Mumbai or Delhi, and there is a particular company which has got 5-6 branches in 5-6 different areas of the city, and in each of these branches they have computers and they want these computers to share information among each other. They could create a metropolitan area network out of these computers that they have, and that would be an example of what is a MAN, metropolitan area network. So that's briefly understanding what a LAN, WAN and MAN and what they stand for. Let's quickly understand this in terms of diagram. Now this is the LAN diagram. Let's say there's an office with one server, so one main server is there, and there are 5-6 different workstations, and these workstations are all connected to the server, and these workstations can then share information among each other. This would be an example of LAN. The most privately owned and links devices to in a single office building or campus. In a single office building or campus that already I have explained to you. Next would be to understand what is a wide area network. As you can see here, different cities are there, and in each city we have a LAN, and these LANs are then connected to each other, and that creates a wider area network, right? Third is the metropolitan area network, MAN, metropolitan area network, where we have a city in which we have a factory, a warehouse, a regional branch office, a central office headquarters, and within the range of 160 to 200 kilometers, and all of these are connected to the central office headquarters, and that would be called as a metropolitan area network, right? So smallest reach LAN, then comes MAN, and the largest in terms of geographical area and reach is WAN, that is wide area network. So that's about types of computer networks that we see. Next we'll look at some of the important network devices, that basic devices that one can be familiar with even if one has not studied computer science in this graduation or in depth. So let's understand. The first one is LAN card. So when you want to connect two computers, how will the computers be able to communicate each other? First thing that we need to install in the computer is a LAN card, which is also called as an Ethernet card or network interface card. Let's understand what is the LAN card. It looks like this. It can be plugged into your motherboard. So the computer has a motherboard. It is a master chip board in which your central processing unit CPU is there, your RAM is installed, it's connected to the hard disk and other devices through buses, and that you'll see that motherboard in every electronic computing device. Even your mobile phone will also have a motherboard in which there will be a RAM, there will be a storage device, there will be a computing device, that is a processing device. So we can connect this in a computer using connect it to the motherboard, and you can see this socket here. This is where the LAN cable goes into, and once we have this, we can start communicating with other devices which are connected using this particular LAN card. So a LAN card or network adapters are building blocks of computer network. No computer can communicate without a properly installed and configured LAN card. So nowadays when we get a laptop and that laptop has Wi-Fi, what you do is just click on and you can search for the wirelessly available internet connections and then connect to them. but there is a LAN card installed, comes pre-installed in your laptop. That is how your laptop is able to communicate with other devices or even connect to the internet, right? Even your mobile phone would have a network adapter which will help your mobile phone connect with the internet. Okay, so LAN cards are the building blocks, are the main network adapters which help your computer or any other electronic equipment communicate through a network. Next is your hub. So this hub is the central connecting device in a computer network is called a hub. So when we have, suppose there are 10 computers in a small office, and all of these offices, all these computers are connected to a hub. So there's a LAN cable is connected to the computer, and that LAN cable is connected to a hub, and all the computers have a LAN cable going into the hub. It is through this hub that computer number 1 is able to communicate to computer number 2. Alright, this hub will store the address of all the computers, and when we want to access any computers through the hub, that we are able to access. So every computer is directly connected with a hub. When data packets arrive at the hub, what the hub does, it will broadcast that to all the computers. It's a broadcasting device. The hub will not discriminate between computers, or to select the computer to which that particular data packet has to be sent. What the hub does, it once it receives a data packet, it sends that data packet to all the computers connected to the hub, and the computer, the destination computer, is the one which uses his other computers will discard that information. Okay, when data packets arrives at the hub, it broadcasts them to all LAN cards in a network, and the destined recipient picks them, and all other computers discard the data packet. That's how the hub works. And this is an example of a diagram. So you can see there's a hub, a kind of a device. You must have seen this in offices, and all the computers are connected to the hub. The central connecting and device in a network is called. So every LAN will have a hub. Every man will also have hubs, right? Okay. All right. Now let's about your hub. Then let's come talk about switches. Switch is an intelligent connecting device. So what we do is that, suppose there are in an office there are 10-15 different working zones, and in each working zone there are 10 computers, and the 10 computers in each work zone, let's say work zone 1 are connected to hub number 1, and work zone 2 is connected to hub number 2, and so on. We have small networks in each of these workstations. Now these hubs could be then connected to a switch, so that now all of these computers can start communicating with each other. So what is a switch? Let's understand. A switch is an intelligent device that maps the IP address. Now I told you about the hub, and say what the hub does is, once a packet comes into it, it sends it to all the network adapters or the LAN cards, and the LAN card which is supposed to receive will receive, others will discard that message. But a switch is not like that. It will send it to the IP address with the MAC address of the LAN card. It will map the IP address. So if a packet is being sent to a particular IP address or a machine address, then it will be sent only to that particular computer. That's what a switch does. Unlike the hubs, a switch does not broadcast the data to all computers. It sends data packets only to the destination computer. So you can see here that we have a work group 1. It's connected to a hub, and that hub is connected to a switch. That switch is also connected through a particular hub to a print server. There's also a server to which the switch is connected to, and there's a high powered PC also to which, and all of these are connected to a switch. And when data travels in the network, switch will decide where this packet has to be sent to. If that packet is destined for a particular hub, it will be sent to that hub, and once a packet comes to that particular hub, it will be sent to all the computers in that particular work group or work zone. That's how a switch works. So understand these differences between what is a hub, what is a switch. Next, let's talk about a router. So nowadays when we talk about computers, we always talk about a router. So we want to connect to the internet, we need a router. So if you have a Wi-Fi connection in your home, a wireless connection in your home, you will be, let's say you need an ISP. So for connecting with the internet, what are the things we need? First of all, we need an ISP, that is an internet service provider. Examples of ISP could be Airtel, Reliance. All of these are examples of your ISP, internet service provider, right? Hathaway and so many other, right? All of these provide you with the internet services. Now what you do is this, let's say you have an Airtel internet connection. Then they'll provide you with an optical cable, also a telephone connection. And using this optical cable and telephone connection, they'll bring a wire, they'll install a router in your home, and they'll put the optical fiber in the router. The router will get the internet, and then if it's a Wi-Fi router, you can connect your mobile devices or your laptop and other Wi-Fi enabled devices to that particular router. So ISP itself is the internet service provider. Okay, and this is your internet. So from the internet, information comes to the router. Router is a very intelligent device. It knows everything about where the packet has to be sent, and according to that, the packet will be sent to the destination computer, to a server. From the server, it will go to a switch, and from switch it will go to different computers as the destination address. That's how a router works. The router is a communication device that is used to connect two logically and physically different networks. Two logically and physically different networks, two LANs, two WANs, and a LAN with a WAN. The main function of the router is sorting and the distribution of data packets to the destination based on their IP address. So router can read the IP address of the source as well as destination. In every IP, what is called as an IP frame, there's a 16-bit source address and 16-bit destination address. So with the routers, it has the capability of reading and understanding the source address and the destination address of each of this packet, and then send it accordingly to that particular destination. That's what a router will do. And then we have this concept of a modem. A modem is a short form of modulation and demodulation. Like a simple one-mark question can be there about what is the full form of modem. So it's modulation and demodulation. What it does is basically it converts an analog signal that the modem receives and then converts it into a digital signal and then sends it to your computer. So it helps you connect your computer to the internet using a phone line. As you can see here, for the phone line, there's a splitter. So we have an outer connection. So you suppose BSNL or Airtel is giving you a phone line. So using a phone splitter, that connection will be sent to the phone line as well as to the modem. The modem will then dial up a number. So we sometimes say a dial-up modem, and then connect to the internet and then provide that internet service through a LAN cable to your computer. That's how a modem works. Let's understand here brief theory part of the modem. A modem is a communication device that is used to provide the connectivity with the internet. Modem works in two ways: modulation and demodulation. That's the full form of modem. It converts the digital data into the analog and analog to digital. This is just now I explained to you. The analog signal comes through the telephone lines to the modem, and they're converted to digital information, and then that digital information goes to your computers, and then your computer sends digital information to the modem, which converts it into analog, and using the phone line sends it to your ISP, that is your internet service provider. All the routers that we have today in our home, so you have the Beetle router or the other routers that come with your different ISPs, all of them are combination of a modem and router. So they're not just a router, they're not just a modem, they're both modem and routers. Some of the ISPs will give you a separate modem. So you'll see there are two devices which you will have in your home. One is your modem and one is a router. So that's also something that we see. So a modem is the one which converts the analog signal into the digital signal and digital signal into the analog signal. Clear? Now also there are two types of modems that you have, and you should know the meaning of these two types and what do they represent. One is the ADSL. The ADSL modem, that is your asymmetric digital subscriber line, ADSL. You will see in your home you have an ADSL modem. You should ask yourself, what is this ADSL modem? It's an asymmetric digital subscriber line. Basically it means that the device is not symmetric, it's asymmetric. That means the download speed and upload speed will not be same. In an asymmetric modem, the download speeds and upload limit will not be same, whereas in a symmetric device the download speed and the upload speed will be same. Let's see here, understand. It's basically a digital subscriber line, connects a data communication technology that enables faster data transmission over copper telephone. So if you want to have a faster connectivity using a copper-based copper line telephone connection, then that is where you need a asymmetric digital subscriber line rather than a conventional voice-based band modem can provide. Okay, in ADSL upload speed, the main concept is this: in ADSL modem, the upload speed and download speed is not same. Okay, now the other type of modem that you will see sometimes in offices particularly is a DSL modem, a digital subscriber line. Again, for faster connectivity with the internet, is a device used to connect a computer or router to a telephone line, which provides the digital subscriber line service for connectivity to the internet, which is often called DSL broadband. Now in DSL modems, download speeds and upload speed is always same. So that's the main difference here between an ADSL modem, which is asymmetric digital subscriber line, and a DSL modem, that is a digital subscriber line. Both are used to connect for faster connectivity through copper-based telephone lines that your ISP is providing, internet service provider is providing to you. And for a broadband, we have to use a DSL ADSL modem. If you see, the earlier modems were not ADSL or DSL, they were all traditional modems. There would be a voice-based dialing of the telephone line. You would hear the modem dialing numbers with the beep sounds and connecting, and often that connection would be lost. Another thing that you will observe when we had a normal traditional modem, that sometimes you would not be able to use the phone service and the internet together. So if you have using the phone service, you could not use the internet, and if you're using the internet, you would not be able to use the phone service. Okay, or using the phone service would disrupt the internet connection. But with the digital subscriber line, that's not required. You can use both the services at the same time. So that's how we have this concept of ADSL and DSL. And A stands for asymmetric, other three letters are same, digital subscriber line. Remember that asymmetric means that the download and upload speed will not be same, whereas only if it's DSL modem, that means it will be having the same download and upload limit will be speed will be same. Next, we have to understand along with the network devices, a quick understanding of the TCP/IP model and the Open System Interface model, OSI model. Although this is an advanced concept in computer networks, and it's not very likely that you get in-depth questions based on this, but just to give you a quick understanding, an OSI model has 7 layers, where layer 1 is the physical layer. This is the layer where normally your Ethernet cable will work, right? This is your physical layer. And so when you have two computers, so peer-to-peer connection, OSI models and TCP/IP model both talk about peer-to-peer connection. So two computers are there, we connect them using a physical line of Ethernet cable, and that is your physical layer. Different types of Ethernet you can say standards will be there, which you will see Ethernet 2.001 to something, that standards are there. These are standards that are used for connecting creating different types of networks. Now next is your data link layer. So once your information comes from one computer to your computer, it first comes at the physical layer and then it moves up to the data link layer. The data link layer is the layer in which your network adapter all of these things, network cards, all of these things will be at the data link layer. From the data link layer, it will go to the network layer. Now router normally works at the network layer. The job of the router is to understand the IP address and everything else, and then from the network layer it goes to the transport layer, where basically we have two types of protocols. One is the TCP, transmission control protocol, the transmission control protocol, or the UDP, the user datagram protocol. UDP is the user datagram protocol. So these are two protocols which work at the transport layer. So once the network layer identifies the IP address of the source and destination, it sends the packets to the transport layer. The transport layer basically looks at the packets frames and takes out the data from the packet, and then it goes on to the session layer. Now what does the session layer do? It opens a session. So basically session layer is where the port numbers will be there. For every type of communication you need to open a port number. For example, for HTTP, Hypertext Transfer Protocol, the port number is 80. So you open the port number 80 and then you are able to send information through that port number. You start a session, you close a session using the session layer, and from the session layer it goes to the presentation layer. The presentation layer is where most of your protocols will work, right? Different types of protocols are there like DHCP and FTP. All of these protocols work at the presentation layer. After the protocols in the presentation layer are able to extract the information, then they are able to send that information up towards the application layer, where the user directly is able to interact with the applications. Like an internet browser is an application layer software. Okay, so an application layer software, the user will be the one who will be interacting with only the application layer software. Everything else will be working below that. So that's a very quick and easy way to understand how a peer-to-peer connection in a computer network works. So data comes from the physical layer, travels up to the application layer, and again when the user will feed some data through the applications in the application layer, it will travel down, it will go to the presentation layer. Based on the protocol, it will select the right port number. So for FTP, the protocol, the port number would be 50. Then again from there data will go to the transport layer, where data will be divided into packets, and every packet will be flags will be there, and other such redundancy check and cyclicity check. All these checks will be there. The data will be broken into packets in the transport layer and sent to the network layer, where the source address and destination address will be added using the IP and IPv6 protocol. Then it will go to the data link layer, from data link layer to the physical layer, and from the physical layer it will go to the destination computer. That's how basically a computer network or communication between two devices happen. Now the advanced form, or you can say a simplified form of the OSI model, is a TCP IP model, in which what happens, the application, presentation and session layer are combined into one layer, and that layer is called the application layer. Transport layer is as it is, and then the network layer is called internet layer. The network layer of the OSI model is called the internet layer in the TCP IP model, and the data link and physical access physical layer of the OSI model are combined and called the network access layer of the TCP IP model. Now this part of the discussion today is something a little difficult, or something unfamiliar completely for students who have not studied computer science post their school level. Okay, so if you find this confusing, just understand the names of all the layers which we have in the OSI model. That should be mostly sufficient. Now don't expect a question of TCP IP model to come in an IBPS PO mains examination. If you're giving the IBPS specialist officer examination, then we need to have an in-depth understanding of the two models that I'm discussing with you right now, the OSI and TCP. Otherwise, this is what we should do about this is just learn the name of some of the basic protocols like TCP, UDP, STP, FTP, which is file transfer protocol, IP, which is internet protocol, and know the name of the layers starting from layer 1 physical up to layer 7, that is the application layer. A brief understanding of how each of these layer functions also I have explained with you without using too much of technical terms and context, just to make you understand what is this diagram that I have presented in front of you. Alright students, so here I have completed with you the basics of computer networks. The main focus should be on different types of networks and different types of network devices. They could probably come as one question in the examination, and that should help you in solving the questions in the reasoning and computer aptitude paper of the PO mains as well as clerical mains examination. So I'll keep this session till here today. The next session will start at 11:30, where I'll be discussing with you some of the questions of mathematics that are very different in the IBPS PO mains paper of 2018 based on memory. Some of the different and unique questions which came for the first time in the PO examination in the year 2018, and we expect something very similar to come in the PO mains examination this year too. So join with me at 11:30 to discuss and understand, at 12:30 sorry, to discuss and understand the different and unique questions that were there in the PO mains 2018 questions, and what should be our strategy for solving those questions. So thank you for now, and I'll be waiting for you at 12:30 to join with me for the next session. Thank you.